Hey, good evening. Am I audible? Hello? Am I audible?
Yeah, yes, ma'am.
Okay. Okay, so today we are going to start week 9. So if any of you have any doubt from week 8, before that you can ask.
Week 9, I believe we have not get content of week 9.
Week 9 is not released yet, huh?
Yeah, I believe by Thursday it will get released.
Okay, okay. So week 8, I saw the PA was done. So that's why I thought that week 9 will start. So up to week 8, anyone has any doubts? Or we can just solve a PYQ paper today. Okay, let me share my screen. Can I see my screen? So we'll just start with this PYQ paper since we have already covered all the content released up to week 8. Before quiz 2, we are going to do some revision. Okay. So this is the paper from May 25 term. Okay. So whatever is in this paper till that we have already completed the syllabus. So the first question will start. So a list is given to us and an empty list is there. So for each number in A, check condition number. So this check condition is some procedure that is going to take every number from this list one by one, right, as parameter. And then if that check condition procedure returns true, then you can add that number to your list, this empty list B. Right. So if at the end of execution, B contains 3 and 5. So out of this entire list, check condition only gave true for 3 and 5. So only these two were appended to B. Right. So we have to check the correct code procedure for check condition. So we have to check that for which procedure definition only B will get appended with 3 and 5. So check the first option. It is saying J equals to 2 and flag is false. So J is assigned 2, flag is assigned false, while J is less than X. So as long as J is less than X, we'll run the while loop. So for the first iteration, X is 3. Right? So here while J is less than X, so J starts from 2. So 2 less than 3 is correct. So first iteration is going to happen. Now, if remainder x comma j is equal to 0, that is if you divide x by j, then is the remainder coming 0? Now, in our case, that is not correct, right? So 3 divided by 2, the remainder is 1. So in that case, flag will be set to false, right? But in this flag is set to false. So this remainder will be 1. So this if condition is not going to satisfy, so flag will be not set to false. Flag will remain false. Now, is this correct? Flag was already false. And if this condition was also true, then also flag will be false only. So is there any scenario that in this option flag will ever be get to, set to be true? No, right?
No, no,
That
yeah.
means whatever value we are returning, that is always going to be false. So this number is never going to be appended if we use the first procedure definition. So this option is wrong. Second option, let's check. So here flag starts with true, and then if this condition satisfies, then it is set to false. So x is 3 and j is also 3. I'm starting with the first number in the list, that is 3. Now j is also set to 3. So is 3 less than 3? No, right? That means we will never get to enter this while loop at all. So this will return true for every iteration. That means this check condition will always give true because we are not going to get to enter the while loop. We have to just return this, right? So flag can never be set to false here. So this procedure is also not correct because if this was the correct definition, then all the numbers from list A would have been appended to list B. Here j is set to 3. So again, I'm starting with the first number where x is 3. First flag is set to false. So here also there is no scenario that flag gets set to true. So we don't need to check further. Both flag variables are set to false. So this has to be a wrong option. Check the last option. J is set to 2. X is starting with 3. Now first flag is set to true. Now while j less than x, so 2 less than 3 is correct. What is the remainder? It is 1 if I divide 3 by 2. So this condition is not satisfied, right? So flag is not set to false. Instead, j is incremented, right? So j becomes 3. Now next, there won't be any more iterations because this condition is violated. 3 less than 3 is not going to let you do any more iterations. So you're going to return whatever the current value of flag is, which is true. So now 3 will be appended. So what is the next number in our list? I mean, this has to be the correct option since the other 4 are wrong. So let's check how this discards 8. So next x, if I take 8. Now j again starts with 2. Give me 1 second. Okay. So j again starts with 2 here. Now my x is 8. So 2 is less than 8 is correct condition. Now if I divide 8 by 2, then I'll get remainder as 0. So this if condition will satisfy, flag will be set to false, right? And now no matter how many times you iterate through this while loop, your flag is never set to true again. So once flag is set to false, it will remain false until the end of the iteration. So you will return the value false as well. So 8 will not be added. So like this for 5, how it is working, 5 also gets added, right? So your j is 2, initially x is 5. So 2 less than 5 condition is correct. Now 5 will never divide and never be fully divided by 2, right? So the remainder is never going to be 0. So this flag, right, it is initially set to true. Now since the remainder is 1, so here flag is not set to false. Instead, j is incremented. So next j is 3. Again, 3 less than 5 is correct. But again, the remainder when you divide 5 by 3 is 2. So flag is again not set to false. Next j is 4. 4 is also less than 5. Again, the remainder is 1. So again, flag is not set to false. Next iteration, j becomes 5. 5 less than 5 is invalid. So you will return the current value of flag, which is true. So 5 also gets added to the list. This is the correct option. Any doubt in this one? So the next question is, what is the value of result at the end of execution of the following pseudocode? So there is a
So,
procedure called build list, right? This
ma'am,
takes, yeah.
ma'am, in previous question,
Hmm.
15 also in uh, ma'am, please show me question. Yes, ma'am. Ma'am, 15 also in A set. So what about
15,
15?
15 is not in your list, right? In the resultant list, 15 is not there. So you have to see why 15 is discarded. So again, j will start from 2. Your x is 15. So 2 less than 15 is correct. But 2 doesn't again divide 15, right? The remainder remains as 1. So next you will again increment this to 3, right? And then
Okay, ma'am.
here, so like this you can continue.
Remainder is 0.
Okay, wait, let me see. Okay, so this will start with flag true, then 2 is less than 15. So remainder is 1. So nothing will happen. Then j is incremented.
It
So
is
now when you
false means
divide, the remainder will be 0. Mhm.
0 and
So
it will be
flag will be
false and
set
it
to
won't be added,
false.
right?
So it won't be added. So that's the
That's
reason,
correct.
right? Whenever you get fully divided, it will not get added.
But ma'am, Z is only 2, not
So
also 3.
j gets incremented, right? After every iteration. Here j
Okay.
equals to j plus 1. So we
Okay,
will
thank
check
you.
for all values of j until 14.
Okay, ma'am.
So this procedure build list takes a list. So this is some list that it takes as parameter. Now it is creating an empty dictionary called scene dictionary and a result list, which is also an empty list. Okay. So for each item in a list, now something is happening over here. We will do this in the with the help of the example that's given, right? So the data is already given here. This is the list. Now this is passed as parameter to your build list function. So this is your a list basically. Whatever this returns will be stored in result. So we are asked what is the value of result, right? So we'll just work it out with this example. So first value is for each item in a list, what is the first item 4? If not is key, scene dictionary item. So is 4 initially a key of scene dictionary?
No.
No, right? Because it is an empty dictionary. So we will create a key and value pair, right? So if not is key, this will give true because is key is false, not of false is true. So scene dictionary item is set to true. So let's build the dictionary also side by side. So for 4, now I have created this key value pair. Okay. Also in result list, the item is appended, but is this normal append or is this reverse append? This
Reverse
is
append.
appended from the
Reverse
beginning.
append.
Reverse append.
Reverse.
So since it is currently empty, it won't show any difference. I'll just add 4 like this. Now go for the next iteration. Next item is 1. Again, 1 is not a key, so we have to create another key value pair. So 1 set to true. Now 1 is again appended to result list. So again, 1 is appended from the beginning, right? So now it is 1 comma 4. Next is 4. So now we already know we have a key for 4. So not of is key, this will not give true anymore because is key is giving true, so not of true is false. That means we already have an entry for 4. So anything will be done in line 6 and line 7? No, right?
No.
Because the if condition is failing. Now next item is 5. So 5 is again not a key, so we'll add it, the key value pair 5 is to true. Then the dictionary is updated. Now result list is also updated. So now it looks like this 5, 1, 4. Next again for 2 we have to create a new key value pair. 2 is again appended from the beginning of the list. For 1, do we need to create any new entry in the dictionary? No, right? Because 1 is already present. So nothing will happen for 1. For 3, there is no entry. So you'll create one key value pair and again add 3 to the list. So 3, 2, 5, 1, 4. And then you have 2, which is again a part of the dictionary only, so we don't have to do anything. For 6, it is not a part of dictionary. So again, add one more key value pair, 6 true, and this dictionary is ending because we have exhausted all elements in our A list. And this starts with 6, 3, 2, 5, 1, 4. So which option is correct? This
Yes.
one, right? This is clear for everyone? Any doubt?
Yes. Yes, ma'am.
Okay. Let's check for this. So what will be the value of frequency dictionary at the end of execution of following pseudocode? So whatever is stored in this frequency dictionary is what we have to return. Right. So again, this is the dictionary. This is the list that you are passing in your count characters procedure. And this procedure obviously is going to return a dictionary which is stored in frequency dictionary. Right. So let's start again like the previous one. We'll just work out the value that is given, the data that's given. So initially frequency dictionary is empty, right? It has nothing. Now for each C in char list, so this is your char list, that is the B list that is given. It is only passed as your passed as your list, right? So what is the first element? A. Is it a key of frequency dictionary? No, it is empty initially. So we will create a key value pair. So we are basically counting the frequency of each character. That is how many times each character occurs in this list, right? So going by that, for now we have only seen one entry for A. So if it is not a key, if we are creating a new key, then the value is set to 1. That is, we have seen one occurrence of this character. Now for B also, you will create this same entry. B is 1. Again, A, when it comes, it is already a key. So you're just going to increase the frequency by +1. So now A is to 2. Right. Similarly, for C, we'll create 1. For B, again, increment. So now B, we have seen 2 occurrences. So you don't need to build this whole thing. You can just count how many times A is present. So 1, 2, 3, 4. So in the frequency dictionary, ultimately when all iterations are over, then for A, it should be stored as 4 frequency, right? Then for B, you can count 1, 2, 3. So it will be B3. For C, it is 1, 2. So C is frequency 2. And for D, it is
पाणी देता
1
का
and 2. So again, D is also 2. And we have one E also. So for E also, it is just 1. So which one is the correct option from these four?
first
A4, B3, C2, D2, E1. So this is correct.
yes
Anyone did not understand this question? So question 4 is saying the following pseudocode is executed using scores dataset. What will be the values of A and B? So what will values of A and B represent at the end of execution? So scores dataset is again our student dataset. So we're starting with an empty dictionary. Now the while loop opens, we will iterate through all the cards in scores dataset. So while table 1 has more rows, we'll pick a row and check that if is key dictionary D and X town city, that your current card is the town city of that student already a key of dictionary D. So initially it is empty, obviously. So every time you see a new town or city, you have to create the key, right? So it will come to the else part and you will create the key. So if for the first card, let's say I have also the physics marks is required for the value, right? So let's say first card I have Delhi and the physics marks is let's say 65. Right, so now my D dictionary has an entry like this, Delhi 65. Now let's say the next card that I pick is also from Delhi. The student has scored 17 physics. Now you check if is key. So for Delhi, we already have a key, so we don't have to create. So come to the nested if. D of town city. So what is the value stored against the key Delhi for now? 65. What is the current physics marks of my card? 70. So is 65 greater than 70? No. So it will not be changed, right? So the if condition fails. Now next card if I get, which is also from Delhi, but here the marks is 60. Now in the nested if, D of town city is 65, which is greater than 60. That means we have found a lower value of physics for this particular town or city. So we will change, right? So Delhi is now going to store 60. That means what is this part doing actually till line 13? When this is over, this D dictionary against each town, city, what is the value representing? The lowest mark scored in physics from that city, right? Like for Delhi, if 60 is the lowest, so it will not be updated anymore. So for Delhi, I can say by looking at the value that 60 is the lowest mark scored in physics from Delhi among all students who are from this city. So once this is done, now you come to line 15. So A is set to 0, B is set to 100. So for each Y in keys of D. So what are the keys of this dictionary D? Town, cities. Right. So it will give you a list of unique towns and cities. So if B is equal to D of Y, that is for every city we are checking is the marks. So let's say, let me give some entries here. So Delhi 60, let's say from Kolkata, the lowest is 70. From Chennai, let's say the lowest is 50. From Bangalore, let's say the lowest is 45. So like this, let's say 4 entries I have. Okay. So what is the first town city? Delhi. The value is 60. So B is starting from 100. So is 100 equal to 60? No. Next, if you check, is 100 greater than 60? Yes. So now A is set to 1 and B is set to 60. Okay, let me take one more city here. Let's take Mumbai, which is also 45. Okay, so now my B is set to 60, my A is set to 1. Next city is Kolkata. For Kolkata, the physics score, lowest physics score is 70. So again, start with the first if. Your current B is 60. So is 60 equal to 70? No. Is 60 greater than 70? Also no. So nothing will happen for Kolkata. Next come to Chennai. So it is, the lowest marks is 50. So your B is still 60. So is 60 equal to 50? No. But 60 is greater than 50. That means we have now found a lower value for a particular city. Right. So I will again set A to 1 and B will be set to 50 now. So every time we find a lower value, B will be updated and A will be reset to 1. So now check for Bangalore. 45. Is this equal to your current B, which is 50? No. So update, because 50 is greater than 45. So A will be again set to 1 and B will be set to 45. Now the last city is Mumbai, which is also 45. Right. So current B is 45. So is 45 equal to 45? Yes. So now you will just update A and increment it to 2. Now see, after this, if I, for some XYZ city, if I see that the lowest marks is 30, then what will happen? Again, A will be reset to 1 and B will be set to 30. That means some new low has been found, right? So what is A actually storing at the end of execution? What is, okay, first tell me what is B at the end of execution? B gets updated when you find a lower physics marks from a city. So B is the lowest physics marks scored in all the cities combined, right? Lowest marks scored in physics among all cities, that is stored in B. Every time you find more than one such cities where the lowest marks have been scored, you add 1 to A. So A keeps count of that how many cities are there from which that lowest marks have been scored. So now tell me which option is looking correct. First is saying A is number of cities where students score the lowest marks in physics, and B is the lowest marks in physics. Is this correct?
No.
This is correct, right?
Yes, ma'am.
B is storing
Yes,
the
correct.
minimum marks, and A is the number of cities, right? The others are clearly wrong. This is
Yes,
highest
ma'am.
mark.
Because it's highest.
Yeah, so these two are directly eliminated. This one is wrong. Why? The number of cities where students score the lowest marks in physics is fine, but B is wrong. It is not
Yes,
highest, it
ma'am.
is the lowest scores. This is clear for everyone?
Yes, ma'am.
Okay, so question 5 is saying following pseudocode is executed on words table. What does the list contain? What does the list L contain at the end of execution? Right. So words table again means each card contains a word, the letter count, the part of speech, and the sequence number, unique sequence number. So initially we are starting with an empty list L. We have to find out what this list represents at the end of execution. Now A is also a variable which contains none. So A is a string variable. Now read the first row X in table 1. So see, we are reading the first row from this words dataset outside of the while loop, right? Now A is carrying the part of speech of that card. Okay. So let's say the first card I pick, let's say sequence number 1. So this has, let's say, part of speech as noun. Okay. Now A is set to noun. While table 1 has more rows, now you start your while loop. So now you will read the rest of the rows of words dataset line by line, one after the other. So next row you pick. Let's say I have picked the second card. Here the part of speech is, let's say, word. Right. So if x dot part of speech is equal to noun. So what is your current part of speech? Verb. It is not a noun. Right. If it was a noun, then only you could have gone to this nested if. So for this card, nothing will happen. Right. You will directly go for the next iteration. But before that, you have to do something. A has to be updated. See, A does not fall within any of the if blocks. This if block closes here, this if block closes here. So regardless of whether any of the if conditions are true, A will be updated every iteration. Right. So A is equal to current card's part of speech. So now previously your A was set to noun, now A is set to verb. Now let us pick the next card, which is, let's say, a noun again. Okay. So again, check if the part of speech is noun for the current card. So this matches, this is a noun. Now you come to the nested if and check that what is A? What is the part of speech stored in A? Right? That means what is the part of speech of the previous card or previous word? Is it an article? So this was verb. It is not an article. If it was an article, then in L, I would have stored the current word. Okay. So now let me take two more examples and this will be clear. So in the next card, let me say this is an article, the next word. Okay. And A is obviously again updated to noun because A is updated regardless after every iteration. So now your A is noun. The next card is an article. So is X dot part of speech a noun? No. So nothing will happen. It is an article. So A will be updated to an article. Now the last card, let's say for this example, I'm picking is again a noun. So now your line 8 condition checks out. So part of speech is noun. This is fine. Now you come to the nested if. What is the part of speech stored in A? That is the part of speech of previous word. Is it article? Yes. Currently A is also article. So in L, you are appending the current word. That is the word present in this card, number 5. So what does L actually represent? It definitely represents a list of nouns because we are checking that X words part of speech is noun. But what other information can we give from here? That this noun was preceded by an article. That's what we're checking, right? Every time you check that the previous word was article, then only you are appending X to L. So which option is correct? List of nouns that come immediately after an article. Is this correct? Or is the second one correct? List of articles that come immediately after a noun. The first one is correct, right? Because we are appending the X word. And for X word, I'm checking the part of speech is noun. A is what? A is carrying the part of speech of the previous word that came before X. Right? So it will be a list of nouns that come immediately after an article. Okay. So these options are very close to each other. So be a bit careful.
Ma'am, could you please repeat?
Yes. You're asking anything?
Ma'am? Hello.
She was asking to repeat.
Ma'am, could you please repeat last?
Yes, yes. See. Basically, why I took all these cards is so that you can understand how A is getting updated and what is the significance of that. So A gets updated regardless of whether any of the if conditions work, right? Because it is outside the scope of the if blocks. So after every iteration, A will be updated with the part of speech of the current word. So see, I started with a noun, right? That was the first card, which I already read before the while iterations even began. That is in line 3. So then A was set to noun. Right, then I started reading rest of the cards. So next card was verb. So again, for this card, the part of speech didn't match. It was not a noun, right? So I didn't check the nested if. But A was updated. A was now changed to verb. Next card was a noun. So this part of speech equals to noun condition was correct. So I came to the nested if and checked if the previous word's part of speech, which is stored in A, was an article. But that was verb. So I couldn't append anything to L because this if condition failed, the nested if. But again, A is updated regardless. So now A is the current word's part of speech, that is noun. Next word is an article. Okay. So now you check, is X dot part of speech a noun? No, it is an article. So nothing will happen in the if blocks. So you come outside and in line 13, you again update A to article. Now the next word is again noun. So first if is true, X dot part of speech is a noun. Now, next nested if is checking whether the previous word's part of speech was article, which it was. So A is currently set to article. So then I am able to append X word to L list. That means when am I going to be able to append the word to L list? When the word is a noun and it is immediately preceded by an article. Right. So what is L going to have at the end of execution? It is going to be a list of nouns that come immediately after an article. Right. So an article and then followed by a noun. So this noun will be in your list. Clear?
Okay,
Ma'am,
ma'am,
one
got it.
question I have.
Hmm.
Ma'am, in this case, like first, when we are writing that move x, like row x in table 1, and then we are
Hmm.
writing a equal to x dot part of speech, we are basically storing the first words part of speech here. But ma'am,
Not
here,
storing. X dot part of speech, this is comparison operator. We're just checking whether the current word's part of speech is a noun. Right.
no,
Storing
no,
is this.
yes, I was talking about a only. And then it is written move x to table 2. So if we have
Hmm.
already moved x to table 2, then why we are again in the while loop, we are starting from table 1. So
X
we
is
start,
X is just an iterator variable, right? It does not actually represent a particular card. This first card in my words dataset was read outside of the while loop. That means once you read the first card, it is removed from the words dataset into a separate table called table 2. Then in the while loop, you start reading from the second card onwards. Why we did this is because we need A to be updated with the previous card's part of speech every time. So let's say if I started with my first card as article, right? Then A would have been set to article here only at line 4. So A would contain article. Now the next card I read, if this was a noun, now this you are reading inside the while loop. So read the first row X in table 1. Now this is the row you are reading because this row has already been moved to table 2 outside of the while loop. So currently this is your word. The part of speech is noun. So you come to the nested if and check what is A containing the previous word's part of speech, which is an article. So that means now this word can be stored in L list. Right. Inside the while loop, we are starting from the second card onwards. Because the first card will never be added to L list. Why? Because it is not preceded by anything. The first word is not preceded by any word, right? So we will actually start checking from the second word. Is it clear?
got it, ma'am. Yes, ma'am, understood.
Okay, this one is saying it is executed using shopping bills dataset. At the end of execution, A represents maximum number of unique items sold by a shop. Okay, so max number of unique items. So choose the correct code fragment to complete the pseudocode. So D is a empty dictionary initially. Now you start your while loop. So this while loop is looping through the shopping bills dataset. Now whatever you do here is what you have to fill in, right? The code. Now the while loop ends here. Then you have a variable which is set to 0. And after that, in line 10, for each A and keys of D, that is, however the dictionary has been populated in this missing block of code, we'll go through each of the keys and we'll check that if A is less than length of keys of D of A, right? That means keys of D is what? Keys of dictionary D. Keys of D of A. What does that tell me about dictionary D? That it is a nested dictionary, where each
Yes,
key
ma'am.
also stores the dictionary as its value, right? So keys of D of A, like it looks like this. Let's say this is D dictionary, A is some key. Against that also some dictionary is stored. When I say, so here there might be two keys, let's say K1, K2. So when I say D of A, this gives this dictionary. K1 is to something and K2 is to something. So when I say length of keys of D of A, it will give 2 because there are two keys. Right. So this much I can tell that D is a nested dictionary. And every time I see that length of keys of D of A for any particular key A is greater than A, this variable A, capital A, then A will be set to that length. That means basically this is finding maximum, nothing else. Right. So let's try to figure out what D actually is. We have to make sure that at the end of execution, A represents what? Maximum number of unique items sold by a shop. Right. So from here, can I just infer that D of A is nothing but a list of unique items? So this K1, K2, these are all unique items stored as keys. Right, because that is what A is actually storing, length of keys. When I say length of keys of this, so it is counting what? How many keys are there? That means how many unique items are there? That is only getting stored in A, right? So we have to make sure that this D dictionary is populated in such a way where this A has to be some shop name, right? And against that shop name, we will have a dictionary which has a track of how many unique items are sold. Each unique item is also stored as a key. I think this is how it is going to be. Let's check the options now. So first row is read from shopping wheels data set, right? Let's say this is the first card I did. Okay, from let's say Big Bazaar. Now, what is the first option saying? You check in if that is this shop name already a key of dictionary D? It can't be because D is initially empty. So in that case, it is saying that if it is already a key, that is if is key, that means is key is set to true, right? If it is already a key, then is key will give true. Then it is saying that if it is already a key, if Big Bazaar is already a key, then you enter an empty dictionary against it. Is this correct? Or should I put the empty dictionary when I encounter Big Bazaar for the first time?
Yes.
Right. So this here is wrong. From here only I can discard this option. When it is already a key, then you do not reinitialize it with empty dictionary, right? Then you add something to the dictionary. So option B is saying if not is key, if Big Bazaar is currently not a key of dictionary D, then you create this key value pair
Yes.
that against
Yes,
Big Bazaar,
correct.
right? Empty dictionary is stored. Else, now let's say I pick another card which is also from Big Bazaar, right? So now I'll come to the else part because not of is key will give false because is key is true in this case because Big Bazaar is already a key in my D dictionary. So in the else part, what you're doing, D of shop name, right? That means D of Big Bazaar. This is storing what? Empty dictionary as value, this one. Here, item is set to true. Okay, but does each card contain only one item? There is an item list, right?
Yes, ma'am.
I have to go through each item and check. So this one is also wrong because it is just
Yes, wrong.
not saying what is this item, where is this item coming from, right? So this is also wrong. C option is saying if not is key, then you create the key value pair. And then outside of this, see, when I encounter the first card for Big Bazaar, right? Here, let's say I have some items XY. For these two items XY also, I need to keep track that these are unique items bought from Big Bazaar. So once I create the key value pair, then I will run a for each block. So for each item in x dot item list. What is in x dot item list for this card? Two items, X and Y. So for each item, I will set the value to true. That means now against Big Bazaar, the dictionary is storing this. X is to true and Y is to true. So two unique items we have seen from Big Bazaar so far. Then it will move on to the next card, right? See, this part of the code I have to fill in here. And then again, once this is over, you go for the next iteration of the while loop and pick up the next card. And then do the same. If it is already a key, then nothing to do. Right? See, if it is not a key, then you create a key. And then you go through each of the items. But if it is already a key, then this if will give false and you will simply go through the item list and whatever is a unique item, you will keep that as a key. So option C looks correct. This looks correct.
Yes,
But also check option D once. D is saying that if is key, if it is already a key, right? If it is already a key, then for each item in X list, X dot item list, you check the item and you set the value to true. If it is not a key, then this empty dictionary is what you're creating. So here, what is wrong? See, the answer is given as C. So what is wrong in option D?
The empty list is creating after that, right? So it won't list out again, right? The loop is ending here itself.
Which loop?
There's
This-
no loop because
empty,
suppose there is a first card and it is not
Empty
taking
list won't
account of
create,
first
right,
card.
for dictionary.
It is just creating the shop name.
See, if
Yeah.
if it is already a key, right? Then you don't have to create any key value pairs. So next your job is just go through each item in the item list and create a key value pair against that shop name.
Yes,
So what is
ma'am.
wrong here?
We are initial.
They're just initializing the dictionary, but it is not listing out, right? It is not verify the item list, right? Here.
So that is happening here.
Yeah, it is happening here, but it is here. It is not happening, right? Here, just dictionary only. It is creating empty list. Suppose that it is ending that loop right here.
No, it
So
is
that is why
creating
it
an
is
empty dictionary against it.
yeah, it is creating the empty dictionary,
Right.
but
So
it
for
is
the
not
first
verify
guy,
that list item. The
see
list.
the wrong thing here is when you see the first card for a shop, right? Like if I see the first card for Big Bazaar and I have two items X and Y. So in that case, will the if give true? This is the first card I have seen for Big
No,
Bazaar shop name. So if
No,
is
it is
true,
not.
so I'll come to else.
Hmm.
Right, I'll come to else and I'll create this entry that Big Bazaar
Yes.
against that an empty dictionary. So
Yes.
after that, see, it is not going through the items of the first card. Next, when you encounter another card for Big Bazaar, it will see that, yeah, it is already a key. So now go through each item in item list and set it to true. But what about the first card items? They are completely ignored
Ignore.
because
That's
in
what
the
I'm saying.
else
Yes,
block,
ma'am.
that's what you were saying.
Yeah, that's what I'm saying.
Okay.
That because it's just creating the first card, only creating the
Right.
dictionary, but
Right.
the item list are not verified in the first card.
So this part should work regardless whether it is a key or not.
Yeah,
Right.
yes.
So that's why option D is also wrong. Option C is correct. This is clear for everyone?
Ma'am, I have a doubt in last option.
Hmm.
Yes, ma'am. In this option, we are in else statement, we are creating another dictionary. So, is
Nested
it?
dictionary.
Yes, ma'am. So, is it the reason that this option is incorrect?
No, this you're doing in every option, right? See, the structure of dictionary D is like this. Let's say for Big Bazaar, that is a key. Against that, a dictionary is stored. Again, for let's say Sun General, there is a key. Again, a dictionary is stored. So for like every unique shop, there will be a key in dictionary D. And what is this value stored against each shop is also a dictionary. In this dictionary, what you're doing is every card that you get from Big Bazaar, you read all the items, and whatever unique items you get, you create a key value pair out of them. So if I get, let's say, item X, so X true, Y true. Now from this second card, let's say I get another unique item Z. So for Z also true. So after the end of execution, this dictionary D should give you what, that against each shop name, you're getting a list of all the unique items that have been purchased from that shop. Right. So that's what the question is asking, that A should represent the maximum number of unique items bought from the shop. So you're getting this length of keys of D of Big Bazaar. Right. So this will give you what? How many unique items are bought from Big Bazaar. So like this, you have to compare among all shops and find out which is the longest. This one is wrong. Why? Because whenever you find the first card for Big Bazaar, right? That means at that point, it is not a key of dictionary D. So you have to create the key value pair, right? So you come to the else part. But after creating, see, you are not checking the elements of this card, the first card. You have to also check the elements and make an entry for them if they're unique elements, right? But from the second card onwards, when I see another card for Big Bazaar, then this is key is correct. So you're entering the if block and then you're going through the item list and doing that. Against each unique item, you're saying the value is true. But that is not happening for the first card. That's the mistake here.
Okay, ma'am.
So-
Understood.
Okay.
Okay. Thank you, ma'am.
Okay, so this is saying we have a non-empty list called auth list that stores the names of all authors in the library table sorted in alphabetical order of author names. So it stores names of all authors in this list sorted in alphabetical order, right? So there is one element corresponding to each book in the table. So this results in many duplicates because one author has written multiple books, right? So if let's say Kalam has written 5 books, and there will be 5 entries for Kalam in your list. Now all these entries will come what? One after the other consecutively because they are sorted in alphabetical order. So it will be like Kalam, 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 like this, 5 entries together. So the following procedure attempts to extract the unique list of authors. So from this list of duplicates, we have to find out the unique list while preserving the sorted order. Right, so the pseudocode might have some mistakes and you have to identify the mistakes if any. So let's say we have 3 books, okay. Actually, let's take a few more. So let's say I have 6 books. Okay, the author for the first book is A. So it is stored. For the next 2 books, the author is B. So they're stored one after the other. Then again, other 3 books, the author is C. So that original list looks like this. Now I am supposed to get the extracted list of unique author names. So it should look like A, B, C, but you have to preserve the alphabetical order. So from here to here, I have to go. Right. So for that, I have written a code. You have to find out where the errors are, if there are any errors, right? So unique list is empty. This is the list I'm trying to build. Previous is a string variable set to none. Now in unique list, you append the first of auth list, that is this original list. So just take my example in unique list. If I append the first item, which is A, so it looks like this, right? Now previous is set to also first of auth list. So previous is also A, that is the author name. Okay, now you run a for each block. So for each X in rest of auth list. So in the rest of this auth list means that everything except the first element, right? So I'll go through all these elements one by one. And what will I check? If X is equal to prev. So prev is set to A. Is X any of these items equal to A? No, right? We have B, B, C, C, C. So none of them will match with A. So nothing will happen here. But see, prev is set to the current X after every iteration. So let's check the first one. So the first X is your B. So is X equal to prev? Prev is A, X is B. No. So come here and prev is now set to B. Right. Now again, check. When x is, what is the next x? Also b. So now prev is also b, next is also b. So x is equal to prev, this gives correct. So now in unique list, you are adding the current x. So unique list becomes a comma b. Again, prev is updated with current x, which is b itself. Now go for the next iteration. Now your x is c. So is x equal to prev? Prev is b, x is c. This is not correct. So now prev is again updated. So prev becomes c. Now check the next one. Now your next x is also c. Right? And your prev is also c. So c equals to c. So this one, unique list, will it be added? Yes.
Yes,
So
it is added.
A, B, and C are added. But it is not over yet. Again, prev is updated, but prev remains C because the current x is also C. Now the next x is C again. So again, x is equal to prev condition persists. So again, I have to append C. So is this a list of unique elements? No. So
No,
where
ma'am.
is the error?
Ma'am, in
Five.
option 5.
So
Five.
5, what is the error?
Ma'am, it is
What should I do?
X is exactly equal to prev.
not equal
Then
to it should be.
That
yes,
means
ma'am, it
we
should
should
be
check
not
that x and prev are not equal, right?
yes, ma'am.
Then only we are going to add the current x to my unique list.
Yes, ma'am,
So
it
line
should be
5 is definitely an error.
Hmm.
Any other errors are there because this is an MSQ? Anyone can find any other errors? See, prev has to be updated, right? Every iteration, prev needs
yes,
to be
ma'am.
updated. So line
No,
8 is
ma'am.
definitely fine. Line 2 is just unique list. You're adding the first element
Ma'am,
of the
no
list.
other error.
But see, line 5, line 2, both have errors. Why? Because you are already adding this first element. See, in my example, you didn't catch this, but there might be a list which looks like this, right? Now, let me fix this line. Okay, if I put not equal to. So now your unique list is first of auth list, that is A. It is in there. Now previous is also first of auth list, which is again A. Now you go through each of the elements in this list, right? Rest of auth list, that is from here. So first element is A, right? X is not equal to prev. Is this correct?
No, ma'am. No, ma'am. We are storing the first element without filtering.
The first element is stored regardless.
Yes,
Right.
yes,
ma'am.
ma'am.
That means here both of these statements are wrong. So if you remove this, now you try to enter. So both the A's will be there in the list,
Yes,
right?
ma'am.
Because first A is already entered and then next you compare with the prev and again entered A. So line 2 and line 5 both have error. These questions are a little bit harder to solve because you don't know what is the use case and what is the test case you should be working with. So there are a few scenarios. Okay. This one is saying following pseudocode is executed using library dataset. Let P be a list of authors and assume that after the execution of pseudocode below, dictionary of X, where X is a key, stores the number of books having at least 200 pages. So what are our conditions? At least 200 pages written on or after 2000 by author X. So that means this dictionary has, what are the keys of this dictionary? X is nothing but author name, right? So let's say I have an author A. Against that, it should store what? The number of books having at least 200 pages written on or after 2000 by this particular author. So I will go through all books of this particular author and filter out that which are the books that have 200 pages and are written on or after 2000. And whatever that number is, let's say n, will be stored against this author name. Right. This is what dictionary stores. So again, this is an MSQ. You have to choose the correct code fragment to complete the code. So initially dictionary is empty. Now for each author in P is a list of authors. Of course, every author will be in this list, right? If there are no books written by an author which is at least 200 pages and written on or after 2000, then you just store 0, right? So initially against each author, we are storing the value 0 because we haven't calculated the number of books yet according to the conditions. So once the dictionary is created, so initially dictionary looks like this: author A 0, author B 0, and so on for every other author. Now you actually go through your library data set. Now the conditions have to be filtered out here, right? So for each author, you have to check how many books he has written where pages are at least 200 and written on or after 2000. So first option is saying first we'll check if is key, that is this X dot author, current card's author is already a key of dictionary D. If this is true,
It is
and
correct in this option.
let's see, X pages, that is greater than equal to 200 means what? At most or at least?
At least.
So this is at least. And the year is greater than equal to 2000. That means on or after 2000. So if both of these conditions are true, then we will increase the frequency by 1. That is, we have found one such book, right? Each card in library dataset represents one book. So now next time also if you find the same author has written another book which is also satisfying all the criteria, then again you do +1. So like this, the frequency will keep getting updated. And this will happen for all authors, right? So first option is correct, but it is MSQ, so we'll see the other options also. Here, can I put or here? If an author is not a key of this dictionary D, then is there a point of checking this part?
No, ma'am.
Right. So either one of them is true and the other one is false. That cannot happen. The author has to be a key, and this condition has to also satisfy. So this is
Yes,
also wrong. Now here in option C, we're starting with two variables C and D, which are both set to false. Okay.
Yes,
Now
ma'am.
you
It is
start with the first step. So this one is checking if the author is a key of dictionary D and the pages are greater than equal to 200. This is fine. At least and is key both are getting checked. So C is set to true. Basically, it is breaking down the two conditions, nothing else.
yes.
Against if is again the next if you're checking whether it is a key and year is greater than equal to 2000. So then D gets set to true, and then you check that if C and D, that means if both are true, then only whole thing will come as true, and you increase the frequency.
Yes,
So
ma'am.
this is doing right. So this is doing exactly what option A is doing.
Yes.
So this is also correct. Option D, see. Here everything is same, but again you're putting a
Now
note.
in line 8, the or
Or-
statement is.
Or statement.
This is not optional, right?
Hmm.
Any of them can be false. That is wrong. Both have to be true. So this is wrong. So A and C are correct. This is clear for everyone?
Yes, ma'am.
Okay, so these are comprehension type questions. So you have the common data and then you'll have two questions based on that, question 9 and 10. So let's solve this pseudocode first. So this is again using your words data set, right? So B is first set to 0. You have an S list and you have a W list. So S list is empty, W list is also empty initially. While table 1 has more rows, read the first row X in table 1. Okay, now I'm going through all the rows in the words data set. So for every card, I'm going to check what? Every card contains a word, its part of speech, its letter count, and it's the unique sequence number of the card. So for every card, I'm appending the part of speech of the word to W list. Right. If X word ends with a full stop, that means I am definitely reading sentence by sentence, right? That's how the words data set is. So every word of the sentence is stored in a separate card, but they are in order, right? So if I have this, I am a student, right? So whatever is the part of speech of these three, they will get stored to W list, right? Because see, W list gets appended regardless of checking any other condition. When will this if be checked, or when will this if give true? When I go to the last word of a sentence, which is followed by a full stop. So that means when I come to student, so X word ends with a full stop, yes. Then you inside this A variable, you're calling the procedure do something with the current W list. Okay, so I'm just writing these as the part of speeches. So currently your W list contains all 4 part of speeches A, B, C, D. So you're calling do something procedure once you reach the last word of a sentence. At that point, W list contains all part of speeches of all words in that particular sentence. So what does do something procedure do? So now the control shifts to the definition of procedure do something. So see, inside do something, it takes a list, which is nothing but our W list, that is list of part of speeches of words of a sentence. So first count is set to 0 for each P in L. That is, I will go through each of these part of speeches, right? If I find that the current part of speech is a noun, then count is updated by 1, incremented by 1, and then you just return count. So basically, what does this procedure return for a particular sentence? Number of nouns in that sentence. Right. And where does it return it? To this variable A.
Yes.
So A will store what number of nouns in this sentence that I'm currently saying. Now you check if A is greater than B, then B is set to A. Okay. B started with 0. So whatever sentence you find, even if one noun is there initially, first sentence, let's say one noun is there, then also 1 is greater than 0, so B will be set to 1. Right. And since you have reached the end of your first sentence, so now you have to reset this W list, because W list at any point just contains the part of speeches of the words of a particular sentence, not all sentences at once. So W list needs to be reset every time you reach the end of a sentence. So whatever was there in W list is now stored in S list. So can I say that if I store a list within a list, S list is a list of lists?
Yes.
Right. So S list is a list which contains multiple lists where, so it looks like this. So A, B, C, D, that is the all the part of speeches of the words from the first sentence. Then again, let's say some X, Y, Z. Right, part of speeches of the words of the second sentence. So like this, it will contain a particular list for every sentence where the list items are nothing but the part of speeches of the words of that sentence. And W list is reset to empty list. So now when you go for the next iteration and start another sentence, you start fresh with a W list, right? Where it is empty. And you again start filling out the part of speeches for every word until you again reach the last word. So what is the significance of this B? What does B represent? See, every time you find an A value which is greater than current B, B is updated. What is this A value? Number of nouns in a sentence. That means at the end of execution of this while loop, B will be containing highest number of nouns in a sentence in overall dataset. Is this right?
Yes.
And what is this S list? It is a list of lists where each element
Where the
list.
noun is present in the
No.
sentence.
No, it doesn't have to be necessarily. See, W list is nothing but part of speech for all words of a particular sentence. So every time you finish a sentence, you are going to store that W list inside S list. So it is just a list of lists where each element list, that is a list like this, each W list
Even
contains.
the noun is not part of this speech also,
Yes,
it will
yes,
be
it
added.
can be part of. Yeah, it can be part of. Let's say a particular sentence is there where there are no nouns. Still, that those part of speeches of the other words will be part of S list. Right.
Okay.
Whatever in a sentence, whatever each word has part of speech, that is stored in W list, and each such W list is stored in S list. So if where each element list contains part of speech of every word of a sentence. So if I have 10 sentences, I will generate 10 such W list, and each will be stored inside S list. Right. Now let's see the questions. This is saying at the end of execution, which of the following statements is or are correct? B represents maximum number of nouns in a sentence across all sentences. This is correct.
Yes, ma'am.
W list represents list of part of speech of all words in the dataset. Does it represent part of speech of all words in dataset or a particular sentence?
Sentence.
Sentence.
So this is wrong. Option C is saying A represents number of noun in a particular sentence. So that's what is do something procedure
Yes,
returns
ma'am.
that is stored in it. So option C is also correct. D saying W list represents the list of part of speech of words in, okay, this is a typo, in last sentence. So that's not correct. W list is generated for every sentence.
Yes.
Right. So again, this is wrong. So A and C are correct.
Yes.
And one more question based on this is this one. What will length of S list represent? So inside S list, what we have all the W lists that I have generated for all sentences. So length of S list means how many W lists are there, as many sentences are there in my data set.
Yes, ma'am.
Right. For each sentence, I've generated a W list and that is stored in S list. That means length of S list is, first option is saying total number of words in words data set. Is it
No,
words?
ma'am.
No. Total
Yes.
number of sentences in words
Yes,
data
ma'am.
set.
Yes, ma'am.
And option C is saying total number of words with the same part of speech in words. This doesn't make any sense anyways. Last option is saying total number of words with different part of speech. Okay, so option C was saying that all the words with same part of speech. So obviously this is wrong. And D option is saying total number of words with different parts of speech. This is also wrong. So it just represents how many sentences are there, that
Number of
many W lists will
sentences.
be there. So B is correct. Okay, we have one more question to go. This is comprehension type again. So you have to answer the following questions 11 and 12 based on this pseudocode. So L is initially a list that contains 0. Then LA and LB are there. LA is a list of lists. And LB is empty, LC is empty. So for each A in L of A, okay. Now we have to solve this. Okay, there is no other way. We need to solve all of this and check what is LC and what is LB at the end. Okay. So for each A in LA, what is the first A? First element, this. For each B in A, that means each item inside the list now. So there is only one item, 1. L of B is appended by the item, but append from the first. So let me call this first iteration of outer for loop. So this is outer for, this is inner for, right? So first iteration of outer for loop, what is the element A here? This 1, list containing the element 1. That is first element of list LA. Now for each B in A, so now I'm just going to do the inner loop iteration. So first inner iteration. So there is only one element which is 1. So you append that to LB. So in LB now I have 1 present. LB was initially empty. L contains what? Last of L plus B. Okay. So add it. What is last of L? L was initially 0. So first or last, it is 0 itself.
0.
So 0 plus what is current B? 1.
1.
So that means 1. L contains 1. Now, will there be any more inner loop iterations? For this inner for each? Will there be any more iterations?
No,
There is
ma'am.
only one
It is
element.
completed.
It is completed.
Yes.
Right. So before you go for the next iteration of outer for each, 2 more lines are there you need to execute. So let's see LC. LC is appended with whatever is in LB. So it is again a list of lists. So LB is this. This is LC. And LB is reset to an empty list. Now we'll go for the second iteration of outer for. Okay, inside that, let's do the first inner iteration. So second iteration of outer for, what is the next A in LA? This list, 2, 2. right? How many elements are there in this list? 2 elements. So inner for loop will iterate how many times? 2 times. 2. So first iteration, first B in A is 2. So B is 2. L of B is appended with the current B. So L of B was reset to empty. So now L of B contains 2. L is what? See, L was not reset. What was L previously? 1. So what is last of L? 1 only.
1.
Plus B. Current B is 2. So L is now 3. Second iteration, what is the next B? Again 2. Both elements are 2. So B is again 2. LB is appended with this item also. So LB contains 2, 2. L is now what? 3. So last of L is also 3. So 3 plus, what is the current B? 2. So L becomes 5. Any more iterations of this inner for each? No, right? So come out of it, and now you have to
Ma'am,
check
why
the.
we are using a last of L? Because only one
This is
digit, right?
just.
Why always
Yeah,
using
this.
a last of L? There is no
Yes,
meaning,
yes.
right?
See,
Because we are
here if
just
you
adding.
write, it is just
We
a
can write it
syntax.
as
Yeah.
a L, right?
You
We
can
can
write
put it
first of L also, you can write last of L also. It is the same thing.
even
Right.
L
There
also,
is.
right? We can put L also, right?
No, no. If you
L.
write L, that represents the list. That doesn't represent an element.
Okay.
Right. So to extract the element, we are using this last. You can also use first here, since L always has one element.
Okay. Thank you.
With list, you cannot do arithmetic operations.
Okay.
Okay.
Got
Now
it.
you come out of the inner for each, and let's see what is updated LC. So LC is now appended with current LB. So previously LC was this. So it has already one element. Now it has one more element, which is 2, 2. That is my current LB. And LB is now reset to empty list again. Right. So I will wipe off this part. We'll keep the second outer for and go for the next. Okay. Now third iteration of outer for. Okay. So what is the next element in outer for? This. 1, 2, 3. So how many iterations will be there in inner for each? 3. 3 items are there. So pick the first item. So first iteration. B is 1. In LB, you have to append this from the beginning. So this. Okay. L is what? This is L. This was the last value stored in L, 5. So last of L plus B, that is 5 plus current B is 1. So L is now 6. Next, second iteration of for each. What is the next element? 2. B is 2. LB is appended with the B, but from the beginning. So 2, 1. L was 6. So last of L plus current B, that is 6 plus 2. So L is now updated to 8. One more iteration will be there. One more element is left, that is 3. So your current B is now 3. In LB, you appended from the beginning. So 3, 2, 1. This is LB. L was 8. So L is now last of L, that is 8, plus current B, that is 3. So L becomes 11. Any more iterations required for inner for each? No. Right? We have exhausted this list. For now, in the outer for each block, 2 more statements need to be taken care of. This is LC. So LC was previously this in the last outer for each iteration. Now you append the current LB in it. So it contains 3 elements now, 1, 2, 2, and the current LB, which is 3, 2, 1. And LB is again reset to empty list. But will there be any more outer for each iterations also? No, because LA is exhausted. There are no more elements in list LA. So now it is over. Now you go to the questions. First question is asking what will be the value of L at the end of execution? 11.
11. Option C.
So option C is correct. This is what will be the value of LC at the end of execution. So 1, then 2, 2, then 3, 2, 1.
So B.
This one. B is correct. So this question is a bit time consuming, but this will be very easy. Right?
Hello?
Once you solve it. Yeah.
Priya, Rachel.
Okay, any doubt here? So this is done. This entire paper is done. So this is an example of a quiz 2 paper is why I solved this today. And also we are done with your other things up to week 8. So next class.
சிபிஎஸ்சி தானே படிக்கிறா அவளுக்கு
Okay, so next class what we will do is start with week 9 because Thursday is the content release. So we'll start week 9, but see, in this week only we will do 2 classes on week 9. Next week onwards we'll do revision for quiz 2 only. Right? Quiz 2 is on 12th. So next week
Yes.
onwards we'll start revision. All right. Thanks everyone. Thanks for joining.
Thank you, ma'am.
Thank you.
Thank you.